Zero viewers. Because we had to interrupt the stream. We had to pause it.
Tyler said a while ago that they're coupled sometimes. Does that mean that having one has to do with the other one? Can you check whether or not this thing is tight? Like with your hand? You think we want to message Rohan that we're live if you want to tell him? You got like slack on no, that could be because the liquid hasn't gotten into the line yet. Sorry, what? We have seen some improvement. We're not sure if that's... We're not confident yet. It does look better, but we're going to have to wait and see. It might take a little longer for the liquid to... Where are we on tank level? Where are we on tank level? We think it's at the base. Has it been going up at all, or? So the issue is, like, filling this doesn't take very long. Once you actually get to that base, filled in, and that's where we're at. It's just that I didn't want to continue filling because this is leaking liquid. Yeah. So we think we fixed that. The current status is we're basically waiting to confirm that that's true. We are getting some gas through here. I'm not really super concerned about that, but it's less than before. Yeah, before it was worse. Is there a way we can we confirm is there something that's part of the structure that's blocking the markings, or is it with the rocket panel?
It's marked on the side of the valve.
I'm sorry, repeat that?
It's marked on the side of the valve.
I see. Okay.
If we get pressure in the heater lines, I can command them close. And it might help you out.
The valve close?
Yes, if the valve might be if I press on a disc, it closes or opens?
Open. Oh, I don't know.
This will close like press on a disc?
Yes.
Okay. Do we know that it's actually closed? That's bad.
Yeah. That's what I was saying low up before. Yeah.
So we've got a leak, is that right? We've got a leak on the liquid oxygen valve.
Yeah.
So that is the liquid oxygen valve. That is the fuel valve. This one is currently leaking fluid out that way. So that's what we're dealing with right now.
So
I don't understand.
yeah, what about it? Are you able to get it right in there?
Alex, you want to go back to Avionics so we have to close that? Close that.
No, not.
Don't close it. If you have to close it, just so we're there.
Yeah, so basically right now we're dealing with a liquid oxygen valve leak. We are putting liquid nitrogen from that dewar into this liquid oxygen tank. And this is our main liquid oxygen valve here, and it turns out that it's leaking. So we're trying to work through that and fix it.
This is LN2.
Yes.
Oh, yeah. Okay.
We're only flowing LN2 right now, but it is intended later for liquid oxygen. This is just a cold flow. Today's cold flow is only liquid nitrogen and ethanol. We have no liquid oxygen on site. It's just liquid nitrogen. So yeah, you can see we have liquid nitrogen leaking out of the valve. So
Where's the open? Okay. Are you able to tighten it at all?
No, not unless I try to tighten it.
Have you closed it down?
Okay. Hey guys, thanks for hanging on. We had to interrupt. We had to pause the stream for like 30 minutes to move around some hardware. But now we are back out of the site. It's a nice day today. This is our bunker. For those of you who are just tuning in and haven't watched the stream yet, this bunker is where we conduct our engine tests. Today we're supposed to do a cold flow test of the engine where we flow liquid nitrogen and ethanol through the system, just like it would for a hot fire. Instead, the hot fire uses liquid oxygen instead. But right now we're trying to work through an issue. The main LOX valve is leaking. So right now we're flowing liquid nitrogen through the tank, but the main valve is leaking, and we built that valve ourselves, so that is something that can definitely cause issues. We're trying to work through that right now. We can check out the fill system around back and see how that's going. This is the fill system. This is how we take our mother tanks. So we got like helium, we got high pressure helium in those tanks, and that's how we move the helium into our run tanks inside the bunker. So this whole nest of plumbing and wires is what we're using there. And we can actually take a look. We can take a look at the engine controller, which is what the Avionics team built. So here's the engine controller. It's actually, yep, there we go. So this unit here is how we control the engine. We have custom software that we wrote, and yeah, you can see that a little better. It's a custom designed and built PCB that we made ourselves. Well, we had the PCB made in China, but we mounted all the components to it. And so that controls about 32 valves and 20 pressure transducers we read data from. So you can see all these lines going over to the fill system. Some of these lines go inside the bunker. That's over to the fill, the inside hardware, the engine and the run tanks, and then a lot of the wires go to solenoids and pressure transducers on the fill system. All right, let's go back inside and see what the current status is. We're looking to do a cold flow today. Hopefully in like 2 or 3 hours we'll be able to pull it off, but it might not be until later in the evening. So what are you guys testing right now?
We're working on the main seal, which so we're working on the main seal to the LOX valve.
Oh, okay, yeah.
Right now it's being chilled in.
Okay. Fully chilled? You think? Yeah, it looks fully chilled.
It's pretty close. Okay, that can get in there, but can it get in over here? That is the question.
Tell me when to check.
So this is the leak, right?
There, excuse me. Over here.
This is the engine. 3,800 pounds of thrust that will be cold flowing hopefully today, and then doing hot fire tests down the road, hopefully in just a few weeks after the cold flow. We'll have hot fire.
So you want me to tighten this seal?
There's the injector
Yeah. So
inside there,
see it,
looking at the nozzle.
fitting is behind, like under the hose.
Right.
So you can't really grab onto it.
Am I on it?
From what I can see, yes. But
How's it going, Jack?
We're going pretty well.
Put my glove on.
The chill process was faster than when we were testing it before.
Oh, really? It's faster?
Yep.
Why do you think it's faster?
Well, we insulated all of our lines.
Oh, okay.
That seems to help.
Oh yeah, the tank. Yeah, so the tank. This is the liquid oxygen tank, but we are just using liquid nitrogen today.
Yeah, we have to, if you want to look over here.
Yes, as evident by why we are working on it. We would never be working right with a tank that has liquid oxygen inside of it. We would only ever do.
Yeah. Also, everything's low pressure. Pressure of that tank's only 22 psi. That's almost two atmospheres, which in our realm of stuff is actually not that much.
Yeah.
But yeah, all of our lines get insulated, so that's helping with the filling process.
Well, all of the cryogenic lines. So, you know, this is a cryogenic line that is insulated. This is a helium line that is not insulated. So.
Well, actually, that's actually a liquid nitrogen line, but this is an interesting learning moment for why that's not insulated.
We don't want it to be insulated.
Yes, exactly. So the way we do a lot of our cryogenic components for the fill system is something called standoffs. So basically over here we have a pressure transducer and a relief valve, and both those components are not rated to see cryogenic temperatures or liquids. So what we do is we put it on a standoff, and what that does is when liquid oxygen or liquid nitrogen are flowing, they'll flow through this line down here that is insulated, right?
Yeah, yeah.
But there is gas up here that is trapped. There's no way for it to escape.
Yeah, so you're saying, so down here, this is where liquid is, liquid nitrogen and liquid oxygen.
Yep.
But this is, we want this to be gaseous nitrogen or gaseous oxygen. So that way, these components actually, so the pressure transducer and then the relief valve, those are not rated for cryogenic temperatures. Is that right?
Correct.
Yes.
So the gas stratifies in temperature. So down here will be very cold, and you can see frost form when it's actually flowing liquid.
Yeah,
But up here you can touch it, it's room temperature, and that keeps our components safe from cryogenics.
Awesome.
So we only insulate the bottom part of the line because we want that to be cold, but the top part of the line, we want to be hot.
All right, sorry about that. The stream decided to cut out, but we're back. It's working. Okay, so yeah, that was Jack telling us. Jack, our Atlo lead. Atlo is assembly, test, launch operations, so he's in charge of that. So he has built and is operating this system. So we got helium tanks here. Eventually we'll hook up liquid oxygen and liquid nitrogen. You can actually see over here. So this is our the tank that we will eventually use for liquid oxygen. Right now it's filled with liquid nitrogen. So you can actually see it's full and at 22 psi. So yeah, that tank has a relief valve set for 22 psi. So that's all it'll ever get to. But you need pressure inside the tank so that you can the pressure is a means to force it out when you want to move the liquid into a different section of the system. You have to need pressure in the mother tank to force it out.
From what I can see, there's 2 on the helium line, 2 on the retention ring, and a few others in various places, but nothing that should be called.
Is it not leaking anymore?
Okay, then I'm guessing, I don't know,
working on it.
like cold temperature before.
Yeah.
Supposed to be a reading, because someone called it super iffy. Like, I get a proper reading, because someone called it super iffy, but...
That definitely tightened it.
Okay.
Is there any difference?
I'm a little
It's less
on the sense of that, because
coming out.
it's like not moving, like not even noise. I don't know. Did you guys disconnect the thermocouple recently?
I'm next to the thermocouples, so I might have accidentally bumped into something, like the wires.
So you can see snow, kind of like frost and snow forms on this tube because it is, you can see some snow because this is a liquid nitrogen dewar, and this, we have liquid flowing up through here. So the hose is at negative 300 degrees Fahrenheit, and we get basically like frost forming on the top
go
of
ahead
it.
and start the...
It's actually pretty cool.
Wait, don't do that. Don't do that. Let me do this.
Let me see if I can get a shot inside the nozzle shot. Okay, so this is the engine. It's pretty big. We have it on roller bearings.
Let's get an aux tank vent going. Okay.
This is the nozzle.
Also, is there do we have any snoop?
Yeah. Yes, I won't touch that right now.
We're gonna worry about that later.
You want to worry about later or now?
I'm just asking for
He was saying that a different one is reading 138, while this one is trying to read 280. Well, wait, is it possible he was looking at the wrong one just because it was the lowest at the time? that. Just ask them now the lock tank, and not what they're doing is now the lock tank. Does that help?
I'm pretty sure that, okay, I'm 100% sure that the reading I'm getting on the one that we want to use is original. It has zero noise on it, with not communication.
Sorry, which one is faulty?
So, not the lock tank one, there's a different one that's faulty right now, but we're not sure which one.
Hey guys, for those of you just tuning in, this is Massa's Colflow test day. We had a live stream yesterday where we were setting up hardware and getting ready for the Colflow, which we anticipate to happen today. So behind me here, this is our shipping container that we basically do engine testing in. So this shipping container Massa has had for about five to 6 years, and we have conducted 32 engine test fires in it. So when we started, we were doing hybrid engine tests. So we had a 700-pound thrust engine. It was a hybrid engine using nitrous oxide and paraffin wax as the solid fuel grain. Basically, we secured it in there and flowed the propellants into the engine and tested it. And we had many successful tests of the hybrid. Also, a few failures of the hybrid where the wall would melt and kind of everything would just depressurize, and that's an engine failure. And so last year we built a liquid engine. That was the first one that we flew at the IREC competition. We were one of the first teams on the pad, and we were able to launch that to 4,000 feet. That was a pretty good time. And so this year we are working on the Base 11 Space Challenge. So in there you saw, just a few minutes ago, you saw the engine that we're building for the rocket that will be going to space. The predicted apogee is, we're targeting 400,000 feet. The Kármán line is at 330,000 feet, but we're going a little bit higher for some safety margin on that. And so the engine required for that rocket is about 3,800 pounds of thrust. And so that's about 4 times bigger than the liquid engine we built last year. So it's a pretty big engine. And we're just getting into the cold flow testing. Over the last 6 months, we've been doing manufacturing of the engine. About a month and a half ago, we just finished manufacturing, and then ever since then, for the last month and a half, we've been doing component level testing, testing small sections of the engine together, like the injector. There's a few components on the injector, and then building up the entire engine in its full assembly, and then doing pressure tests with it, doing tests where we flow water through the injector and see what flow rates we're getting, and all that. So that's where we're at, and now we're ready to do a full cold flow, which means we put it in its testing configuration. This is how we're going to do a hot fire test, all the hardware together in there. And here, actually, let me walk over to the fill system so I can show, I can talk, and then you guys can see the fill system too. But it's actually kind of loud over here. Let me know if it's hard to hear, because there's some venting going on, so that's the hissing that you hear. But yeah, so the cold flow test is where we gather all the hardware required for the hot fire. So the fill system behind me, helium tanks, we're going to have liquid nitrogen tanks. We're going to have ethanol that we're flowing into it. Here are our avionics. Right there, that's our avionics setup. So basically the cold flow is exactly like the hot fire, except that we one, don't have liquid oxygen, and 2, nothing ignites. So there's no fire except for the igniter going off, but the igniter gets extinguished by the liquid nitrogen. So we want to test how the igniters work. And actually, you can see right here, we have a bag of igniters. It's kind of funny. They're actually styrofoam cups. We cut styrofoam cups in half and glue it together. And then inside the styrofoam cup is a chunk of solid propellant. So to ignite the engine, we light off that APCP, and then it burns through the cup, and then the propellants, we flow into the engine, and then ignites, and then we have sustained combustion. So that's how that works. And actually, we can come and look at the fill system. So you guys might have seen a little bit earlier in the stream, or the other streams we've had earlier today and yesterday. This is a fill system. This is how we take the gases and liquids from our mother tanks. Basically, the mother tanks are the ones you get from the supplier. You pay for the helium, you pay for the liquid nitrogen or liquid oxygen. They give it to you in a tank. But we have to get that into a separate tank inside the bunker that we can pressurize. So the tanks that the suppliers give you can only go up to such a high pressure, but we need to feed the engine at about 700 psi. So we built our own tanks that are in the bunker right now, and that's we fill those tanks up with propellant, and then we feed it into the engine through our valves, and then that's how we run the engine here on the ground. So let's take a look inside the bunker. It actually is pretty loud in here. They're filling up the liquid oxygen tank with liquid nitrogen to chill it. Basically, if you're putting cryogenic liquids in a tank, it has to be already cold. If you put a cryogenic liquid like liquid nitrogen inside of a tank, if it's hot, it'll boil off instantly. That's like putting, it's just like water boiling. The liquid is too hot for its container. So let's check out what they're doing. It's kind of loud, so I won't be able to talk in here, but
I'm gonna head back to that side too. Oh no. Can I look up? Oh, thank you.
So right there we have the engine. Up here we have the helium tank, the helium run tank, the fuel tank right there. So helium, fuel, oxygen. That's the engine.
Yeah, so that's not moving at all. I mean, that's in the brick pretty tight, like the plant, so I don't think it's that big of a deal. I don't think tightening from this side is helping that much. Certainly that doesn't look as bad as the worst we've seen it.
Yeah, pretty frosty. So that valve, the valve is what I'm zooming in on right now, and it's fully chilled. So there's liquid nitrogen inside of it, and it's very cold. And right now, Ethan is using a bottle of cryogenic leak checker, basically Snoop, that works for cryogenic components. Yeah, so essentially that is soapy water that we're putting onto different sections of the valve to try to see where the leaks are coming out of.
It's actually clean Snoop,
It's actually clean Snoop, so it's good to use in an oxygen environment. It's not Snoop. But we do use Snoop for other things that aren't cryogenic or oxygen. It's basically just soapy water. It's special soapy water that you put on something, and then if there's a crevice that's leaking, it'll bubble up. So that's a great way to tell if something's leaking. Let's take a look inside the nozzle of the engine. So this is the combustion chamber. This is the nozzle. The injector is up here. It's actually kind of hard to see, but the injector is in there. These are the load cells. This is the thrust stand. So that thrust stand will take up to 5,000 pounds of force. It's as you can see, it's bolted down into the floor. This engine will produce about 3,800 pounds of thrust.
Oh, wait. Oh, I can tighten that much more now. Is that any better?
It's better. Once you get metal and metal, it will either not
So, I can talk about the process going on.
What?
I can talk about that going on with valve.
Yeah, you don't know what's going on? No, you did. You did. What is going on?
It's
So Jack, tell us what's going on with the valve right now.
So it sounds like a leak is probably a bad thing, but it's actually kind of normal. So
Okay.
we're good.
Yeah, we got it.
Nice. I'll talk.
We
about
got
that.
it.
So basically, what happens is when metal Our valve is made out of stainless steel for oxygen. And when stainless steel gets to cryogenic temperature, it starts to shrink. And so does seals. Seals are in seals and valves are either made out of Viton or PTFE.
Teflon,
yeah,
Viton, PTFE.
So those
Luna
seals,
N.
yeah, a lot of different materials, but we generally use Viton and PTFE. PTFE goes on oxygen components because it's safe for oxygen surface. So when those seals get cold, they start. Oh no.
Oh no. Our gloves got muddy.
When those seals get cold, they shrink down.
Yes.
So when they shrink, they seal not as well. So our valve actually takes that into account. So the fittings have to be tightened when they first are chilled into cryogenic temperatures to ensure that there's proper sealing.
Yeah.
So at the beginning of the day, we leak checked the valve at room temperature and it didn't leak. But when we chilled it, it started to leak. So that wasn't something that was a problem. We knew we had to do that.
So basically, it doesn't leak at room temperature, but it does leak once it gets cold.
And we want to use these valves when they're cold because
Yes.
it's cold liquid flowing through them. So
Yes,
we
that makes sense.
Chill it down and we tighten the valves, and then they stop leaking. And Ethan just gave me a thumbs up, so I think we're probably ready to continue filling and move on with the process.
Yeah, so what are we doing with the tank? So we're putting liquid nitrogen into the liquid oxygen tank. Why? We're not going to use liquid nitrogen to feed the engine to sustain combustion. So why are we using liquid nitrogen?
So probably the easiest way to think about this is if you had your oven turned on to around 300 degrees, and you took a bucket of water and you tossed it in there.
Yeah.
All the water is going to evaporate instantaneously, right?
Yeah.
It's not going to stick around and just get hot.
Yeah.
So a similar process goes on here as we have components that are negative 300 degrees. So there's negative 300 degree liquid oxygen that has to be put into our engine, right?
Into the hot engine.
Into the hot engine. And now the engine isn't hot. It's only, room temperature when we first start to use it.
Yeah.
But negative 300 to 300, negative 300 to 0 degrees is a very large difference.
Yeah.
So we chill everything in beforehand. And what that does is it brings it all down to cryogenic temperatures.
Yeah.
And it takes a lot of liquid nitrogen to do it, but it's easier than using a lot of liquid oxygen.
Yeah. And so right now they're chilling in the tank. Yeah.
So we're chilling it in, so when we put liquid oxygen in it in the future for hot fires, there will be a cold tank and the liquid oxygen won't evaporate instantaneously.
Yeah, sweet. Yeah, sorry for the hissing. The hissing noise is the tank venting out gaseous nitrogen. So it is a little bit noisy in here. So it is a little bit harder to hear, but...
I think it's fine. Now, we do run the risk of the actuation force isn't be enough, but I do think that this will be okay. I don't feel like I was going too tight on that. Yeah. That seemed about reasonable for the Teflon, so I think it's okay. Hold on. I also think, I've got this habit of thinking about this recently. When the chilling at this speed is different than the chilling they were doing before, the housing is probably going to be warmer than what they were chilling. Yes, that's what we discussed. Yeah. Can you grab that so it doesn't blow away? So, yeah, the actual loading condition normally is a little bit different. So, yeah, you can actually touch the valve right now.
Hey, so if you guys have questions about how our system works, what components we have, what they're made out of, how we do things, really any questions about the engine and the hot fire system, the avionics, everything, post a question in the chat. I'm reading the chat, so I can answer it. Yeah, there's a lot of cool stuff, so we want to talk about it, but you guys have to ask the questions. So over here, we can show off the avionics. So basically, the avionics is the brain of the entire system. And right here, this is the custom PCB that we designed and assembled. It has over 1,000 components mounted onto it, soldered on, so it's quite the crazy unit here. So this is the engine controller. You can see we actually have some blinking lights over there. That means something, I don't know what. And then basically you have all the harnessing coming off, going over to the fill system. These are valves and tubing, and then we have some harnessing that goes inside to the engine and all that stuff. So I think someone asked a question. Was the leak on an LN2 fitting or the helium fitting? Gabe, that's a great question. The leak was on the liquid oxygen valve itself, so it was not helium. It was the liquid oxygen area.
I have to see it. Okay.
So, I'm going to continue with the vent. Oh,
Yeah. It's gonna be white.
Yeah.
It's gonna look like what that did when that has
No, you're right. So that's probably going to take a little bit more, but everything else seems to be going pretty well. So for that connection, what we can do, we'll go with the hose pattern. Yeah. See if that works. What connection do you have on the? You want to use that for the lock too, or do you want to use this?
Oh, sorry, I knocked over the SOP. I'll sit now.
My biggest problem is I need to get it to 380. That's isn't as easy.
Alright, so you should start looking through the connections and stuff that we have right now.
It has to be clean. Is that tube clean?
What tube?
The half-inch butt hose.
We do have, yes, yeah.
It is?
Yes.
Where is it?
It's in the cardboard box that's up by, I think it's up by the cement. So, I don't know what recently you covered, but I can go over what's happening.
It's actually very hard to talk over the hissing.
Okay.
Yeah. So
Well,
why
we can,
put igniters in those little cups? Oh, someone asked.
I can step out for a bit and talk. Yeah, that's the best thing. Here.
Yeah, so someone asked the question, why do we put the igniters in those little cups? Basically, the reason why the igniter is in the cup is that during the pre-fire, like before we fire the engine, the igniter is installed, but then while we're filling the propellant tanks, we have to chill the injector. So we actually are flowing liquid nitrogen through the injector, and if the igniter was not in a cup, it would be getting blasted with liquid nitrogen and it would freeze, and then the igniter no longer works when it's frozen. So basically the cup is to protect it from getting frozen. Yeah, so this is Ethan. He can talk about some of the systems we're working with and what we're doing today.
Yeah, so this is the first Colflow of PT-163, our first engine that's regeneratively cooled. This is for the Base 11 Space Challenge. So we're attempting to be the first college to send a liquid rocket to space. This sort of test, the Colflow, is typically done to test all of your procedures and hardware and get an idea for a little bit of the performance of some of the engine, and then allow you to make adjustments before you actually do the real deal, the hot fire.
Yeah.
So you see Jack, our ground ops lead. He's working on some of our ground hardware over there, the fill system, which sort of operates all of the hardware inside the bunker. You got a stand in there which has a lot of systems which are analogous to what will eventually go on the flight vehicle. And then in the center is the engine. You can see it's mounted on a thrust stand. That thrust stand is actually a small replica. It's made to have the same dimensions as a test stand out in Mojave. So that gives us some flexibility on where we can test and when. So I don't know if we'll head in there quite yet because we're doing some chilling, and that's sort of a loud process.
And did you guys fix the leak on the liquid oxygen valve?
Yeah, so earlier, when we started the chill process, the liquid oxygen valve started leaking through its vent port. It has an built-in vent to capture any leaks like that. And so we were working with some of the fine-tuning adjustments on that. There's a few things about the valve that we're learning. We might want to change those features for future valves so that we don't have this sort of issue.
Yeah.
This was a recurring thing we have had, but we seem to have fixed it. And so things are looking good, and we're going to be filling the tank. So
awesome.
Things will be rolling pretty soon here.
Awesome. Thank you, Ethan.
Yep.
All right, so you saw Ethan talk about some of the hardware, the propulsion hardware that we're using today for the Colflow. And now we can take a look at over across the field at the mission control station is what we call it. That's where we set up all the computers, and we have software that controls the engine controller. So actually, I showed you the engine controller, that blue board over there, and then we have some software that we use that that operates the engine controller. We actually wrote the software ourselves. So let's switch the camera view. This is mission control over here. This is our propulsion members. So basically, we have the test operators sit in this camping chair, because that's how you do rocketry. You sit in a camping chair. And then on this laptop, that's where we run the software that controls the engine. The screen is very dim, but you can kind of see some of the software that we're using. So you know, we got some pressures, temperature. I actually don't know what all these numbers are. It's kind of, yeah, confusing. And then we got some live graphs that, yeah. So that's our software. So this is basically where we're situated when the engine fires. Everyone comes over here when we do like high pressure operations. So when we're filling the tank and pressurizing the tank, we all come over here to mission control, and then inside the bunker, that's where we fire off the engine. And you can check out some of our other YouTube videos. We've done a total of 30 engine test fires in this bunker over the years. So it's pretty exciting that we're building on you know, past architecture that the team has used. And yes, the bunker has been tagged with graffiti before. We had to paint over that. Someone came during the night and put graffiti on it. All right, it's gonna get a little bit noisy. So we got the engine right here. That's the engine. We have the helium tank, the fuel tank, and the liquid oxygen tank, which feeds the main propellant valves, the main fuel valve, the main oxygen valve, which goes into the engine. And this is our thrust stand that basically holds the engine in place. And we have our load cells right there. And actually, I think in the comments, someone asked about the load cells.
Sorry, do you have a question? No, me.
Are the load cells on the test stand going to be on the final rocket when you launch? The answer is no. We will not have load cells on the rocket. The way the engine mounts into the rocket is a little bit more complicated, and we're looking for weight savings on that, so we're not measuring the thrust. But what you can do is, if you want to know how much thrust the engine is getting at any time, you can actually look at the acceleration of the rocket. So we're going to have accelerometers and a lot of other flight instruments on the rocket. So what you can do is, you know the weight of the rocket at any point during the burn, because you know the propellant flow rates into the engine. So at any point you can calculate what the weight will be, and you can measure the acceleration of the rocket, and then from that you can get how much thrust the engine is producing. So yeah, ask questions if you got them. We're happy to answer questions. Hi, Chris. So right now, the liquid oxygen tank is being filled with liquid nitrogen to cool it down. That's the hissing that you hear. You hear the gaseous nitrogen at the top of the tank evacuating it and spewing out, and like basically shooting out at a high speed. So that's what's so noisy. I can actually show you the actual solenoid that has gas coming out of it. It's right there. This is the engine. Let's take a look. So this is the mounting for the thrust stand. So basically, the engine can slide along here, and it goes against the load cells, which push against the thrust stand. So the injector is in there. It's kind of hard to see. This is the combustion chamber. This is the nozzle. And then inside the nozzle, you can see, so that's the nozzle. That is material of the combustion chamber, and we have the injector too. Yes, the thrust stand is bolted down onto the structure of the shipping container. So you got, the engine, the thrust stand. The thrust stand is welded onto a plate. This is a really thick plate there. And then it's bolted through the structure of the shipping container.
You have tubes to do it? Like, you're not going to be able to get the tank against the right here.
It's not the right height, then.
Huh?
It's not the right height.
Well, we can shim it up and down.
Or you can't shim it down though.
I can't shim it down. Yeah, but we can shim it down.
Did you have to model the thrust stand structure, or did you just bolt it and hope for the best? No, we did an incredible amount of simulation and structural analysis on that. We made a model. Here, let me see. So we made a CAD model of the entire bunker system. So the walls, the wood flooring, the metal structure underneath. We took samples of the metal underneath and did material testing, so we actually could figure out the tensile strength of the bunker itself, and we put that into a CAD model. And we had a CAD model of the thrust stand, so we put that entire assembly into ANSYS FEA, where you do structural testing, and we applied loads and worst case loads onto the thrust stand, and we found out that it is sufficient to handle the thrust with a good safety factor. So in years past, we have thrown it together and hoped for the best, but this engine is so much more powerful, has so much more thrust, that we definitely did our due diligence with that, because the worst thing would be your engine ripping out of the floor and flying against the wall. Like, we can't have that. So
What's up? Huh?
I don't know what that juicer rated for, but probably not that.
Oh yeah.
The one that came on eBay.
Again, that was not done correctly. There should be a pressure gauge on, like a big standoff with a pressure gauge and a juicer, but
Yeah.
Rip eBay juicer.
Actually, I think the way this fills in is actually through the base, like the line here, and then like fills up there. Because
it's cold.
yeah, that's the thing.
Yeah.
So
I mean, I'll plug it in when we're done and see if that's still alive.
we have
It's probably fine.
we have gotten them like they are rated to -40°C, so you know.
Yeah, it's about -40.
It's really a suggestion. Right, yeah. I mean, please reading the key future. You wanna just for like close that for just a minute here, please. I just wanna like check that we're getting something. Oh, I don't know. I don't think so.
Why is that not white up there?
Was it before?
Huh?
Was it before?
Oh, we close the solenoid.
Yes, yeah, the vent line solenoid.
All right, so the hissing stuff, that's because we closed the solenoid up at the top of the tank. It's actually that solenoid right there that was venting out, and we closed it, so now we're just holding the nitrogen in there.
I mean,
We actually have some cool window viewing ports in here, so
oh, you're doing something.
you can see outside through this port. A lot of times we'll put high-speed, expensive cameras behind here to get cool views of the engine, but we don't want the expensive cameras inside because things tend to get damaged by the heat and flame. And our shipping container comes complimentary with a HDMI adapter, so this is video support for your standard shipping container, like all of you have at home.
When you head back, can you
Open. Okay, yeah. I'm so trying to decode the from. I think actually, like, we're reading from all of them, and that was some weird thing where it just. I don't even know.
What is the temp rating for the valves?
But
So any of the solenoid valves that we're using on the fill system are rated for a cryogenic operation. So those are the commercial off-the-shelf valves we're using, and they're all rated for cryogenics. However, we did build two main propellant valves, one for ethanol and one for liquid oxygen, and you can actually see them. So that is the fuel valve that we built right there, and we rated the liquid oxygen one for cryogenic service. We rated it ourselves by doing some testing. It's not 100% reliable yet. I would say it's probably 50 to 75% reliable at this point. So yeah, but all of our solenoid valves are rated for cryogenic service.
It's like not reading right because he was weird thing with like.
Wait, what would be 330 Kelvin if you offset it opposite of 273? You know what I mean? Like if you're
Not-
reading from
not
273, yeah, that's what I'm saying.
It wouldn't be that simple.
Okay, maybe yeah, you're right.
I also think.
But I think we need a secondary way to verify tank level, not thermal level.
Yes, that's a good question. So we won't be doing phone streams for too long. In the next, probably in the next month, we're gonna get a legitimate live stream setup going. We'll probably be using. So we have GoPro cameras all over the place. We have 4 GoPro cameras that are watching
watching this system, so we'll probably be having like a more dedicated live stream setup. We'll probably have a computer over at Mission Control that is switching between video feeds, and we'll have a commentary table. So we'll get better, but it's funny. We just decided to do this live stream. It was a few days before the Colflow. We were like, hey, let's live stream, because why not? Purdue did it. They had a good time live streaming their engine, the Boomizumi engine. Shout out to Chris. Those live streams were awesome. So we decided that we could follow suit with our own. But yeah, it'll get better. It won't be on my phone forever.
Unless we can do this with just one tube.
I think that's going to have to happen pretty quickly.
Yeah, so unless we want to just do one tube though, we can't do one tube. We can't do
I'm not understanding.
We can't do one flex tube, right? In any way, shape, or form. We should, honestly, but I
mean,
somehow I lost.
if you absolutely can't, and it's like time sensitive, we'll just we might not chill the upstream if we can't. Like if it's like
I think y'all need to revise reliable when referring to locks. Yeah, it's a good comment. It's hard though, because for the main propellant valve, if we wanted to purchase an off-the-shelf solution for that, that would be maybe $10,000 to $20,000 for a valve that is lightweight and small that can fit inside the rocket. So we decided to build our own because we don't have $40,000 to spend on main propellant valves. And obviously, when you build a cryogenic, a large cryogenic valve, you have some trouble. It's not easy. So we're working on increasing the reliability, and we're actually switching some of the design aspects to have high reliability. But yes, it is very hard to achieve 100% reliability on a component. Companies that build valves spend years and years designing and qualifying valves and tweaking the design. We're not a company with years and years to build a valve, so that's why it's only about 75% reliable. But it's good enough to start with, and you got to start somewhere.
Yeah,
we're also doing something that has never been done before, sending rocket to space. So it's kind of hard.
By college team.
By college team.
Yeah. So I mean, the main propellant valve development has been something where we've never entirely built our own valves before. We've done a little bit of actuation, and we learned a lot from that last year, and that definitely went into the design of this valve.
Mm-hmm.
And like all things considered, it's actually.
I'm opening the valve.
Okay, thank you. So all things considered, it's actually gone pretty well so far.
Yeah.
But as far as like what we'd want during flight, we're going to shoot for even more higher reliability.
Yeah. So yeah, the liquid oxygen valve, since it has to be cryogenic, and you can actually see it's all frosted over right now. That's the fuel valve. That's the oxygen valve. So it's all frosted over. The fuel valve is actually probably like 95% reliable in testing. But the liquid oxygen valve, since it's cryogenic, the seals have to be different. Things are just more difficult when it's frozen, so it's less reliable that way.
Probably about to hear a loud noise. And
oh yeah.
Start the vent again.
Yeah, just to warn, the vent valve might open soon, so you might hear some loud hissing in a minute. Where do we get our valves for the feed system? So one company we use is Clark Cooper. I think another one is Rigo. Ethan, do you have some of those off the top of your head?
Yeah. There's so for the fill system, I mean there's a whole gamut of valves in there. I wouldn't say it's really any one place, because most of it, like each situation is pretty specific.
Yeah, so like when we select a valve, we say this valve needs to have this flow rate at this temperature and this type of operation cycle. And then we find a valve that suits that. So right now, the liquid oxygen tank, which is right there, is venting. So there's a solenoid right there that is venting gas from the top of the tank. Sorry for the noise. So this is the liquid oxygen valve. It is fully chilled with liquid nitrogen. It's completely at the cryogenic temperatures. So there's a piston inside that goes down and up and aligns a flow port so the fluid can flow through. And then this right here is the fuel valve. So we just got a question, why is the locked tank inside of the container? So the reason why we do that is, so basically, this is the container, and then right here is the fill system. So the fill system and the container are separated because inside here we have, so outside we have medium pressure propellant, so we have liquid oxygen at, not right now, but for the hot fire, we will have liquid oxygen at 20 psi, ethanol fuel at maybe 10 psi, so we can feed it inside the tanks. But the tanks in the bunker have propellant at 700 psi when we do operations. Right now it's at like 5 psi, but eventually we'll bump it up to 700 to run the engine. So it's separated because if the tank happens to burst, we have one wall that is separating all the other systems. So that way our other tanks have a much less chance of being punctured or exploding or anything. So it's basically a safety thing, separating the pressurized propellant from the unpressurized propellant. And then, so we have the bunker where the engine is, the fill system, and then all the way over here is where mission control is. So that's where we go. It's about 200 feet away from the bunker. That's where we go when we run the engine. We sit down behind the wall. We have our computers that have the software to run the avionics and all that, and the valves. So, good question. All right, let's check out mission control. So this is where we go. But yeah, the shipping container, I guess it belongs to Massa. But actually, technically, everything that we own is technically owned by the university. That's just how it works legally. You know, the students ourselves don't own anything, and since Massa is an organization within the university, technically everything is owned by the university. So everything we use our money to purchase is the property of the university in the end. But they don't really intervene too much. We're pretty independent. We decide what projects we want to do. We decide how we want to do them. You know, what competitions to compete in. So we're pretty autonomous at Massa. Are any of you free to help me out to do the live stream? John, are you busy?
I'm free.
You're free? Okay, so I need to charge this. Do you just want to walk around and like just go and show stuff? Like I've just been like holding it, like looking at the stuff, and whenever people are doing work, just pointing at them to see.
Yeah. I don't know if Ethan wants me up there right now.
Are you
busy? I don't know. I got the walkie back here.
Okay, don't always like waving around. Like you have to.
Sorry.
This is live.
Okay.
Can you help me out? 'Cause I need to charge this. Okay, just like this.
I don't
Just
know.
hold it first.
All right.
Like,
Yes.
you want to use this.
I've What?
It's your chance to talk about what you do.
I don't think that's what this is for. I don't know why Ethan wanted me to have this walkie.
Maybe it's not working. I don't see why you can go. I don't know why.
Yeah, it is kind of weird.
Why are you guys over there? Are you guys like running the?
No, he has a flight controller over there.
Oh,
We're trying to stay out of so we don't want more feet in there, right?
Okay.
Yes. And then Ethan just had me turn on the walkie, so I figured that he wanted it for something.
Okay. Can you help me to go over there? Like, I want to eat something real quick.
Okay.
Like,
Yeah.
you just go over there and show what's happening.
You want to take this? I'll be right over there. So. Sorry, folks. I've got the live stream now. My name is John. I work in the propulsion sub-team for NASA, and we're coming around now. So as you guys see, we're working on chilling in the tank and engine systems, well, the tank systems. Over here, they're working on troubleshooting the avionics. Everything's kind of busy right now. I don't know exactly what's happening. If you have any questions about the engine, now is a great time to ask. I'm pretty technically involved with that, so I can answer any of those.
So the term that the water was reading super high is back to tank. Is back to tank? Yeah, so I'm thinking maybe the thermocouple with the harness was wired wrong. So I'm using the bug. I have a bad feeling we're out. So, right, we need to get this off because right now the liquid is there.
So the temperature inside the engine right now is room temperature. So we actually have nothing chilling the engine in right now.
Which is about negative
Uh,
okay. So the thermocouple is almost currently at 200 Kelvin.
so this is because we're trying to chill in the tank system, not the engine itself. When we fire the engine, it can get up to 3,000 Kelvin. So the type of valves we use were chosen after a lot of careful analysis into what type of valves we could build. The ones we have now are gate valves. Paige has the walkie up front. The ones we have now are gate valves. We actually made the valves for the feed system come from a couple different companies. Oh my goodness. I don't know exactly where I am on being able to say that stuff. Cameron's coming back with something.
I mean, the alternative is, like, this stuff is pretty close. That's pretty big. I don't know if that'll fit.
So when we get the GoPro system up and running, that's definitely something we're going to try and use in the live stream. This is not a permanent solution to that.
I have a feeling that this is going to need to be Can you close that? That will make it switch.
I don't know exactly who the shipping container belongs to, Niall. Certainly the land does not belong to NASA. It's a rent from the university right now. Is everybody gonna?
Wait, what? No, wait. The other solution is wait from the future. Or talking about today?
Yeah, I am. I'm trying to answer them, but there's a lot of people coming in right now.
Maybe not. When you ask me?
So we determined the hose diameter. This is specifically for the main propellant lines, I assume. We are using the same hose diameters we're planning on using for the actual hot fire. So this is based on the actual flow rates through it. So the goal is that you want to have your things not moving at too high velocities. Because as far like with locks, right, you don't want to be flowing too fast to become quickly hazardous. So we're running at the 3/4 inch hose tube size and a similar hose size so that it's as safe as possible.
You're the only one who might know how heavy this thing actually is.
So kind of the process for designing the injector, I've worked on that a lot, and the process for it involved a lot of
Part of the thing is like you're bending this line.
research, careful research, then a general design was come up with, and then lots of flow simulations were done on it, and then more flow simulations, and then more flow simulations were done on it. Yeah, Gabe's right. I've read that thing many times. The 8089 paper. It's a very important paper for designing injectors.
Let's get a step stool. That's what we have this for. You're not gonna fall and like punch your face up. And this is that okay? No.
So they're diagnosing problems with the chilling process. Yeah, it's a very intensive process, and we expected to run into some problems today. So this isn't like unexpected, this is pretty normal. We'll just see how they affect the progress of the Colflow today. Hey.
How's Livestream going?
I'm answering questions.
Oh, good. What
Cameron?
Just wait a little bit.
We had something about propulsion because I asked him to ask those because there's things I can answer better than most things.
I have one.
Cool.
Yeah.
So where we're at right now is we are trying to chill in the liquid oxygen tank using liquid nitrogen. We think it's pretty cold. Like, do we know if it's fully chilled?
It's cold.
Do we have a temperature on it?
We're some uncertainty on our thermocouple reading on that. It's the first time we're using them, so it's reading right now 200 Kelvin, which would be about -70 degrees Fahrenheit.
Okay.
Which seems reasonable because
That's not fully chilled.
that's not fully chilled.
Yeah.
No,
That would
definitely
just be the
not.
gases coming out of the tank.
The cold gas is considerably warmer. Like once it heats up pretty fast. So if liquid starts to rise in there, it will go from -70 to 300 rather quickly.
Yes. So it's getting cold, but we have no liquid in the tank. So by the way, how this works is when you're chilling a cryogenic tank, you think you're filling it up with liquid and then it's cooling down the walls, but really you're trying to fill it with liquid, but the instant the liquid gets into the tank, it evaporates and the gas starts to cool down the tank. So most of the chill process is done by putting liquid in and then it evaporates and turns into gas. You don't actually have any liquid in the tank really when you're chilling. It's only when the tank is fully chilled that the liquid starts to stick in the tank and the level starts rising. So we are trying to work through the chilling process. This is the first time we've done a full chill with like the entire system out here. That's part of the Colflow is like working through all these problems, trying to figure out how the system behaves. So I'm gonna take over.
Yes, that would be good.
All right. Did you answer that question? How do you calculate the pressure losses?
Yeah.
How do we calculate pressure losses through the feed system?
Fuel system?
The feed system.
What's the feed system?
I don't know. Anything really.
All right, we will go to the fuel system. I can explain that a little bit. So every component that you have has something correlated called the CV, which is your coefficient of flow. So basically, everything on here has a coefficient of flow. I'll refer to it from now on as a CV. So, for example, this valve right here has a CV of 1.1. This one has a CV of 0.3, and this has like a CV of like, I think like 4 point something because it's really beefy.
Yeah.
So basically what those correlate to is like, or that's a metric of how much fluid can flow through a valve, and it's a unitless number because it's a coefficient. So basically what you could do is you can like combine all your CVs of a system and get like your system's like coefficient of flow.
Okay,
And
the total CV.
coefficient of flow of like, let's say this entire panel, right?
It's kind of like resistors.
It's very similar to how resistors work, yes.
Almost exactly. It's exactly.
Yes, it's
like
very
resistors.
similar to how resistors work.
Yeah.
And then what you do is then you say, okay, here's my inlet pressure, which maybe will be, 6,000 psi, and my outlet pressure when we vent is 0 psi.
Yeah.
And then you could take the CV and put that into an equation, a flow rate equation, and get your mass flow rate and volumetric flow rate
Yes.
through your system. And then you can also deduce the pressure drop across the entire system and each component from there using a range of calculations and components.
Yeah.
We actually made a calculator for that for compressible flow.
Incompressible flow.
So at the end we have our total system CV, and then you say, if I have propellant upstream at this pressure, I know that it can flow at this flow rate and be this pressure downstream with this pressure loss. So it's, once you know the total system CV, it's pretty easy to calculate flow rates and pressure drops across the feed system. Yeah.
But you can also, you have to take into account tube bends and
Oh yeah.
a lot of other various things, so it becomes pretty complicated pretty fast.
Tube
Yeah.
bends are a lot more complicated to take in. My understanding is that more advanced basically have just figured it out. They've just measured pressure drops across tube bends as like a multiple of the length of the pressure drop just across the tube, which is also a thing that happens.
Yeah. And also, but however, tube bends are an order of magnitude lower pressure drop than like a solenoid valve.
Yeah.
So if you can calculate the CVs of the solenoid valves and combine those, that's like 90% of your pressure drop. The last 10% comes from fittings and tube bends and having the flow go through a smaller fitting into a larger fitting. There's a few different things going on, but it's mostly the valves.
And another thing too is that those calculations are pretty thorough when you have to do this many components and tube bends and all that type of stuff.
Yeah.
A lot of times you can make a lot of kind of simplicities to the problem and say, okay, I don't know if we said this, but a higher CV is better. That means you can flow more.
Yeah.
So a CV of 1 means you flow fluid faster than a CV of 0.1.
Yeah.
It doesn't mean 10 times faster. It depends on your system. But what you could do is you could just look at the limiting CV, it's called.
Yeah.
So let's say you have a system where all the components are a CV of 1, but then there's one valve that has a CV of 0.5.
Oh yeah.
You could very roughly assume that your flow rates will be closer to the CV of that valve.
Yeah.
Through the flow rate of that valve than through the flow rate of a valve with 1.
Yeah.
But that's very, that's a very rough estimation. It also largely depends on your system and your setup.
Yeah.
How that happens. So you really have to know your system pretty thoroughly to make those assumptions.
Yeah. And now this is one of the GoPro cameras that we have. I think we got like 4 set up. So for future live streams for the hot fire and other events, we'll be using the feed from the GoPros and putting them together, like being able to switch cameras and having like a table set up for commentary and all that. So we're trying to do what Purdue did with Boomy Zoomy. Purdue had an awesome live stream, so we're trying to be like that. And over here, this is the engine controller. This is the back side of the board. Our team designed and built that. There's over 1,000 components soldered on. This is the front of the engine controller. This controls all the solenoids. It reads data from all the transducers. So basically, and also you got some blinky lights in there. I don't know what they mean, but they mean something. And then all the cabling going down to the fill system, and then going in to the bunker right there. So Then we got our software that our team has custom written to control the engine controller.
This is done.
None of it's done. It'll look more pretty soon, but it's it works. We can control valves using this. We can read data. So, you know, we got some, I don't know, we got some numbers on there. I don't even know what the units are. But will the engine controller get a box? It kills me to see something so beautiful. Alex, will the engine controller get a box eventually?
Yeah, so eventually we'll design a housing for the engine controller for flight.
Yeah.
And then so the housing is designed to protect it for different thermal and dynamic conditions. So it'll get a nice box. And then we'll do testing. We have a vibe table here at the University of Michigan in the Aero Lab. So we'll stick it on a vibe table with some rough dynamic levels.
Take care of this drawer. I don't know. Time to fix it.
And so we'll shake it, see if it breaks. Hopefully it won't. And also,
how hard are we going to shake it? Are you going to shake it? Let's get a vibe table.
Yeah, so basically, the vibe table is basically a giant solenoid with a plate on top of it.
Oh, yeah.
You bolt things to the plate, and you shake it along that axis.
I actually didn't know it was a solenoid. That's pretty cool.
Yeah, it's just a giant solenoid.
Oh, nice.
And so we'll do vibe testing. We'll try and come up with a way to do shock testing, but I don't know if we'll be able to drive good loads.
Yeah.
That's actually useful. And then we'll do thermal testing on the box with the engine controller as well.
Are we going to do
hot and cold testing?
Are we going to do vacuum testing for some of the other telemetry?
Yeah, so the box will be hermetically sealed.
Oh, okay.
And that should help us. But the big thing with vacuum is like heat dissipation.
Oh,
so
yeah.
Give it a big ass like radiator if we need to.
Oh, cool. Okay.
The testing will really tell us what we need to do. But it's pretty straightforward. It's a box.
Yeah. Awesome. Thank you.
Yeah.
All right.
We're coming up with really innovative solutions.
Oh, really?
Yeah.
Oh, nice. I'm going to set my phone. I'm going to try to set my phone down and get a decent view. I need to go get a battery bank.
You might be able to play that mission control using the radio transmission.
Oh, yeah. I could.
Are you going to up there to get a radio bank? Or?
Jack.
Yeah.
I need you over here doing the same thing before. You're going to put that in your pocket or something so you can use both your hands.
Okay, do not knock my phone over.
Wait, are you leaving or are you just going?
No, I just have to get a battery.
You want to get food too?
No, battery from the generator.
Yeah, but you want to get food on the way?
On the way, there's no food here.
Yeah, like leave.
I mean, I could, but who's gonna do the live stream?
At that
John.
share.
Or
John.
Paige.
Yeah.
Sean,
Literally give it to anyone, but like you do need food.
No, I gave it to John earlier, and he was like, okay, and he's like pointing at the ground, and like, I'm like, God damn it, John, like, you gotta point it at the things.
She's definitely watching us.
I know.
Don't worry, we love John.
We love John, he's great, but he's not good at being a cameraman.
Alright, here we go. We're going to try this.
Oh no. You're all like.
Yeah, pay attention so you don't fall over, or I'll fucking kill you.
Yeah, I'm standing on two beams.
Do we have power in here, or is there a power outlet nearby?
Yeah.
Right there. Oh shoot. Okay. I'll try to set up my phone and charge it then.
Now we're talking. That's right. That's a good idea, Alex. Oh, there we go. Alright, now where's the...
Does that only roughly fit?
Thinking about the rest of it. So now, one of the things is it's going to be sitting farther away. So, pick that up. That's good right there. Right there, like, oh, fuck. I'm
This is very hard setting up my phone. Oh God. I need my phone charger.
Oh, the bottom of the tank is half speaker.
Oh. All right. I need to run and get my phone charger. Premium streaming services. Buy my phone. So yeah, over here we got the generator. Kind of. In the future, we're gonna have better streaming tech. We'll have cameras with different views we can switch to, but right now it's just a phone because we're starting out. All right.
We're gonna be doing the vents again, so
yeah.
What are you guys doing next? We do not noise in here.
Shit. Hold, stand by. Gosh, my phone is like dying.
Use it as a stool.
What?
Use it as a stool.
Oh, yeah.
Very professional footage.
Yes.
Oh, wow.
Oh shit, my phone is like dying on me. Yeah. Oh shit. 1% battery.
Oh, it's starting to move, right?
What? It's supposed to be charging.
Oh, no,
oh 2%. Oh my god. I like can't unplug it then.
Yeah. Okay. Alright, we're definitely doing this. Let's try to do this. Maybe we're parsing this one? Oh.
What?
You could be partially full. That would be hard to know.
Yeah, it's getting warm.
Also, yeah, I'll have to. You might be able to. Test it.
Hey, 3% battery. Yay.
I'm like not sure if the liquid level in theory comes right about to like 3/4.
Yeah.
Maybe it's actually like maybe just above half. So I don't know. I'm thinking it's possible that.
Oh, really?
Yeah. So
eventually we'll see it spit out, which is a very good indication.
Full. If it's not full, then we'll only see gas. So it's possible that there's liquid like filling almost all the way filled, but like we wouldn't know. It's basically impossible to tell. That's the same problem we've always had with HVAC.
That's why we should have put the thermocouple below the fill line, in my opinion. Well, we can add more thermocouples.
This is like really full.
Do you want another thermocouple somewhere?
Right
I
now?
can add more. I have like 5 more thermocouples.
Good.
There's no thermocouple. Stick it right on the bottom of the tank.
Good.
Cool. I hate to be the dude, but
Wait, do we know that thermocouples are making good contact with it? If not, then they're useless.
Yeah, no, I mean, this is good.
I think Jeff used thermal grease, so it should be making pretty good contact.
Okay.
When I was doing my business with this guys, I was thinking very similar thoughts to this guy.
Yeah. Oh, hey. That's like some basic.
Yeah.
Oh. Okay, so that's better than it was just a minute ago.
Yeah, but
possibly start from there.
Okay. Well,
like for perspective, when I stopped the last time, we had vapor shooting out to like around here.
You know what? I'm thinking.
All right, by the way, for everyone watching, I'm charging my phone right here, so you'll probably be getting this view for a little while my phone can get some more battery in it.
Try to, like, if this gets worse, like from here, we'll just switch to that.
Where's that button? As above the end cap, but as close to the bottom as possible.
You want a knife?
So, are you going to show the viewers what a typical NASA food run looks like, or what point is that happening?
If someone can hold if someone can do this,
I will hold the live stream.
Okay, yeah.
How many people are watching?
Call John then, or
John apparently was.
John sucks. John was like, he was like, this is what John was doing. I was like, John, can you do the live stream? He's like, yeah, sure, yeah, I got the live stream, yeah, sure.
All right.
Really, all I have to do is hold it here.
Yeah.
But why can't I just walk around with it?
Well, because it's charging. My phone will die if you unplug it. It's so low. Just fix.
Okay, give it to me. If you want to go get food.
Okay.
Well, unless we can send John to go get food.
Yeah. Well, I have a U-Haul, right? Is this the only vehicle?
You're the only vehicle.
Okay.
Or we can get, if we order Jimmy John, we can just pick it up.
John just went to go get food. So if you want food from Bush's right now, talk to him.
Who?
John.
In what vehicle?
He's not going to Bush's.
That's not real food.
He has a walkie. I just did it. He has a walkie. Talk to him.
So what we're currently doing today at NASA is trying to figure out what food we're going to eat. Also chilling in the liquid oxygen tank. Do the viewers have any suggestions for what to eat for lunch?
I need you to keep this away from the thermocouple. Like, hold this apart. This bowl.
I'm going to sort of get your personal space here.
Fuck. I'm going to try to burn, so.
Hey, well, we have gloves.
Look, I just keep it. Fuck it.
You got it? You still want it?
No, I'll just rip these away.
Yeah. And then we can clean this tape up these days.
John's definitely that weirdo and Bush is right now just walking around like having a conversation on a walkie-talkie.
Can you grab that tape?
I need a crowd glove. Or winter glove. I can get you
There's
I have an actual crowd glove that's right there. That's it. I'm not convinced that they're any different.
Yeah. I'm just gonna like.
Cool. So
This is gonna be really bad.
Around that.
It's wet, so the tape's not
I'll do it so it's like that.
Pretty cool down there.
Oh my god! Wait! Don't tape it too much. Wait!
yeah, just take this.
Hold on. Get a strip off first. Oh my god! Oh my god! Get a strip off first.
Maybe.
You are the worst.
What do I do? That was insane. I'm great at taping now.
What?
What I do?
You were like, just get. Yeah, there we go. That's all I need.
I don't think it's actually a mistake. Or it can't get enough contact. Also, this thermal bead is freezing. Yeah. Wow.
It's almost certainly not ready to try it.
So, what is it made out of? Oh, I do fucking do it. That is a high-tech setup.
Yeah.
A very expensive camera mount. Very professional.
Alright, we're going to do an experiment. I need someone to hold it there, to hold it in place. Alright, I can do that. I need a glove. even rated for cryogenics?
Yeah.
Am I rated for cryogenics?
Okay, you are definitely not rated for cryogenics. You're going to hold this side down.
This is so bad.
Shoulder side
so bad.
to the tank. I know.
You need to fucking charge my
Raise the
phone.
base. And that gap in insulation. Okay, got it.
Okay. Oh, here we go. I'll hang it. You can pause the live stream.
No, you can't. Well, you can if you're on a computer and you can like insert things. Not on the phone, I don't think. This is good. This is good.
Yeah.
Well, at least you have you thought of passing this. Okay, it's charging. Okay. I'm surprised at how many people watch it. It's just like pointing at this and nothing's happening.
We're getting close to some pushes, so it's going to be 20 minutes before we're back with it.
Yeah.
Stand by. I need to reset the engine controller, but that's all we're going to shut off.
Sounds good. John, what were you saying?
20 minutes before we're back with more food. Bye.
Conversation about food in your engine controller.
Wait, what?
What did you say?
Mission control, can we get a status of the donut holes?
Donut holes are gone.
Donut holes have reached critical levels.
Are you checking the donuts or in our engine zone? Yeah, I mean, everyone get off the radio for like 30 seconds so I can read your total levels.
Jack. Soon as you're done here, you're working on the pumping up the tanks, right?
Well, if you need to,
Yeah. Like, assuming it's probably not outside. That's what, right?
well, we're not doing both at the same time.
No, but yeah, like, if we determine we need to, I want to do that in like 20 seconds.
Yeah, that has the same fitting as the last tank.
Oh, okay.
I think. I'll go check.
Well, I don't want to take, you can't take this valve off. That's not going to happen.
That guy.
Okay.
I think I'll check. That's still pretty light.
Okay, so, inconclusive. I'm pretty sure your hand is keeping it warm. I don't know. It's really warmer than this one. So, I don't know.
Yeah, it's pretty weird. Even the insulation guy doing this talk shit over, I'm like pretty sure that like there's gotta be liquid in there.
What happens if I just hold it without a, don't look at it now.
Don't put your finger against it.
It's not against it.
Alright.
Yeah. What we could do is we could have all these thermocouples like way ahead of time installed in like securely fastened to the tank.
220 Kelvin.
And not just tagged on to the
Like
light.
220 Kelvin.
That's pretty warm. Investigate something to verify this again.
I have literally nothing to verify against except for a couple of liquid oxygen. That would help.
You need liquid oxygen?
Yeah.
We could do that.
Do we have enough liquid nitrogen to run the test?
A cup?
No, do we have this like the full test that we're
We have no idea.
What we think though is yeah. We think that yes, we do have enough. Right? Right. We're not out.
Yeah, but at the rate we're burning through it, like
We don't even know.
Do we know what rate we're going through it?
We have absolutely no idea that.
yeah, I would say a surefire thing we should do is we know there's liquid in that other tank.
Yeah.
I know. Representative design? No, he doesn't. What? Oh. We have that nitrogen tank. Now is the time for the nitrogen tank. Wait, now it's time. What? So, if the problem is that you can't get the high enough differential to like actually fill it, then go get the small one. The small one? Is that what you're saying?
Can we get a differential on the tank? Transistor?
Yeah.
Whatever it is right now. You need to plug in on the side of let it levelize and then
That would be it.
oh, it's flowing faster than
You might, so you put it against here, you can use a bracket strap. Yeah, so it's pressurizing itself faster than it can pull it out. It's just following that right now. So, that's just like the height normal thing that well, no, like it is back on the computer here. No. It comes out here, that's when the tank goes back out, and you hear it, you pull it right up there. Zach.
you want that tank to be filling now?
Like right here. Yeah, I want it like here.
That's okay. Let me make sure I'm not being negative. Okay. Wait, you want to get a nitrogen tank?
You and Cameron are working on different things.
I know, but I'm asking you what's the idea behind that one too.
I want it ready to switch.
Not the doer, I know that.
These fucking bricks, you need to throw them away. They're so useless.
I agree.
Stuck in the fucking way. So,
Watch this. I'm getting better. Keep looking at it for just a sec. Press the play button. Watch. Yeah, watch for a sec. Is that any different?
not really. We're only adjustable though.
Yeah, we're like 100 Kelvin off of the lock temperature or LMD temperature. I don't know what would actually CC the tank, but it's not even 100.
You're probably slightly lower, so we're moving in the right direction.
Yeah, we are going down. It is getting colder, but very slowly. Yeah. That's going out. That's not gonna work. You're just freezing the water, dumbass. No, I think it's a little dry. Yeah, put it in the condensation cloud. Yeah. It's nitrogen now. No. All that you can see is not, that's not nitrogen. Well, that's water. It's nitrogen gas. Yeah. There is but the white cloud that is also inside of it is all water. That's like, getting better. Getting better. I mean, but if that's also 15, then it's kind of moot. It's a little PSIG, not PSI. Oh, then, alright, so you can test that. Just close the solenoid for a second, and then see how the temperature is. If that's the case, then you have to have a group. Why? In the last on the phosphorus. Because the doer puts liquid into the tank. The Jack, can you lift up the back end or something? You should get on here. Yeah, it'll be best if you get it straight so the wheel hits the back of it. Yeah. Come on, right here like this. There we go. Wait, what? Come on. Move the camera, it's not used, right? No, let's just get that out of here. Move that camera as well. Go on the ground. Alright. What? Take me here. Yeah, I think 115 is good, isn't it? Yeah, yeah. Alright, we're just gonna have to continue the same. We won't make it across. Oh, okay. So, here. Oh, that's cool. It's actually not that cool. Yeah. I think it's kind of stupid. Can someone else undo that knock? Okay. Yeah, can you go get the regulator that's in the front seat of the gear wall? Go get a ratchet strap to, yeah, to the door there. Where's the regulator we need for this? The regulator? Yeah. For what? This? It's in the car rack. He's already got it. Alright. What else do we need? We're going to need a hose there. That's the key. Can't take me a hot set to think about that. Oh, well, don't look at the fitting. But we'll have it. Alright. You get like a piece of green stuff, like it's like a bar of metal or something. Yeah. So the next question is how the fuck do we get this into the tank? Okay. This has a 3/8 weight lock on it, right? Yeah. Yeah, I can. Okay. So here we go. Oh no, this has some fucked up shit on the end of it right now. Alright, so I can figure it out. This is quarter. No. This is fucked. So you're gonna take it's a British. You're gonna have to take a 3/8 something and wait. What about the 3/8 thing right there? This goes to the suppressor in the tank. You can't just undo it. It goes to the right. So it's pressurizing. Oh, you are pressurizing. Yeah. Yeah. Okay. So if we're gonna do that, then let's wait. There's a plug. Yeah. No, we're gonna do that. Yeah. Okay. So you have basically the idea with that ratchet strap. Yeah. Wrap it. Move this hold and then hit it down out. Okay. And use that. You can flip it around on the other side. You need to bend down all the rest of this before we pull that. You want to do this? I don't know. Let me. Alright, Ethan, I'm gonna disable the valve, and then you can save your system. However you plan on doing that. I don't know what your plan is, but okay. Yeah, that should work. Yeah, that should work. Do you want to do it now or wait like? We'll wait. Okay. Okay. Oh, yeah. Okay, I see. That's the main. Okay, what is that? You instruct me here. Keep calling it, and then I'll feed the hook over to you. Not yet, right? Oh, I see. Okay, yeah. All right, I know how you want to do this. That makes sense. I didn't hear what you said. One more time. Who is this, Jack? How soon are you ready for this? I don't know what the fuck you're talking about. How soon are you ready for this? I don't know what it is. I'm going back with food now. This is like full product. Yeah. The bar isn't tall enough, so it's through a hole in the unit strut. Okay. So just like cut it down. Alright. Like you can pull it through. Right. Don't hold that. Don't hold that. I got one. Okay, there we go. It's not me pulling out, it's the bar pulling out. Okay. I'll hold this here. Oh, fuck me. These left beams with the pressure of my put your hand out and adjust it. Okay, I think you got it. You want it? I'm going to have to get it. It's like, that? Okay, good. Okay. The other one. Ah. Stay right there. Pull back on this one. Pull back on here. Yeah. That's good. Yep. That's gotta be really good. Is that working? No. Fuck me. That's so hard. That's I don't know. This has progressively gotten better. Because it's so gradual, I don't know if it's liquid or not. I'm sure we'll see like if pure liquid does start coming out. I continue to amaze myself when it continues. Okay. Holy fuck. This goes to here. You want it the other way. You pull it. You put it through this direction. This direction here. Yep. Up the hole. Yeah, go through the hole. Yep. And then you pull it tight. Like you pull the whole thing out. If you pull that way, it's fine. And then pull it as well. Now. Yeah. So you go one under. Yeah, I got it. It's taking that. probably should make it a little tighter thing, but it's fine. Okay, all of that, we need to like straighten it. Like this. Oh, yeah, like that. And like this. Pull it out. Talking myself to we're talking live stream. Live stream. Triple the juice. We're doing work. You know this dropper is this tomorrow? Wait, no, it's all the way up. It's not in a fall. It's just the geometry. There's this thing here that this is good. This is not too bad. Just about. Okay. It can like rotate on a single point, but it can't like fall over. That's it. You can't. No. Look at that. It's good. A lot better than it was before. Oh, it's because you got the nitrogen in here. Yeah. Okay, so before we plug the regulator in, before we plug that into the tank, we're going to have to plug the regulator and make sure we set the pressure. Yeah. And we're like, all right, we're not going above that pressure. Yeah. Now there's relief valve, so like it would be fine, but I just don't want to. Yeah. So who's going to do that? One stack gets it over here. Oh, there it is. All right, I need the tank rotator. Okay, so what's on the end there? Is that 3/8? Yep. Okay. Is there any way that we can plug this to be sure we don't over-pressurize the tank? Like, I know we can start it at 0 and go up, but I just want to make sure we, like, set a maximum that we, like, we're not... Oh, actually, this is, like, very fine-tuned. Yeah, I can give you, like, I think I'm 100% sure I can get this off right now. It is off. I am 100... I use this regulator so much I can totally tell you. I need this to be taken out, and that tank to be rotated more. Clockwise. Move very clockwise. Good block. Right hand roll. Yeah, good. That's a little bit more if you can. That's good right there. Alright, pull that door. Left hand is clockwise. Oh, God. Rohan all the time with left hand. I was like, stop it. Stop. Wait. Don't do that again. I mean, I might as well. Why? No, don't. Because I can't screw this in if you screw that in. You can't. Oh, yeah. But also, you can't screw this in until this is unpressurized. Yeah, so can we do that, like, right this second? So turn that off. Okay, so, yeah. All right, we're close. Like, for sure. You see that? Yeah, we're getting closer, that's for sure. This will help us out. What is this right when we get it? That one. Not right now. Not right now. We're working on this right now. Davenport telling us to bring food over here. So. Wait. Oh, if Davenport wants something, give it to him. Okay. Davenport wants something. Keep it away from him. Wait, can we get that valve closed? Is it connected or not? If not, then you take it off.
Yeah, take it off. All right. All right, I'm gonna vent it like as soon as possible, right?
Glad that didn't freeze though. I was sort of worried that that might freeze.
Down up there?
Yeah.
You know what the wrench is fine. I'm not even kidding.
All right, I'm gonna get these things out of your footpath because that.
Okay, I'm opening it. Okay?
You're gonna.
Yeah. Just take a hot bath.
That's hot. That's hot. Just close. Right. It's not connected, is it?
It is.
We're draining that tank?
Yeah, that's what.
There's a check valve.
Yeah, there's a check valve. Yeah, there's a check valve.
Just say, like, that'd be pretty funny. Fucking putting it back in.
Yeah, we don't look at that. That is all ridiculous.
Was that bad?
Yeah, this is the top.
Yeah, I know. Yeah.
I need adjustable wrench here.
Right.
Another one?
Oh, fuck.
Go, you can go. Fingers full of pocket.
Alright, then I need to take that plug off. You can do that.
What part?
That plug.
Oh, yeah, got it. Yeah.
Wait, there's the wrenches.
I want one, but
You don't need one.
I think. Oh, there is one. You can do it now.
It might be really, really hard to get out.
It might be.
You want the crisis
Try
wrench?
really, really hard.
Here, Ethan. I'll give you the crisis wrench. You want the crisis wrench?
I don't need to do crisis wrench right now.
No, it's right there.
Oh, no.
I don't have a crisis wrench.
That's not the crisis
It's the
wrench.
medium crisis wrench.
That's not really
The
crisis.
concern wrench.
Concern wrench.
Moderate concern wrench.
So,
I gotta like get the ice. I mean, it's next to me like that. All right, that's loose.
Hold that.
I'm gonna get out of your way so I don't get trapped in here.
Hold that.
Awesome.
You know, Livestream is the best. Until someone heats that knob all the way to the right and everything blows up.
It won't. It wouldn't. Like the flow rate to that is much too low.
Yeah, no, either your check valve or your relief valve.
Like one.
yeah,
relief
the
valve.
check valve we have here to make sure nothing would get through.
No, the one relief valve on there would be like more than enough. But there's two. So.
If you know what the live stream is good for, when new members want to huddle in here and watch us work, we say, no, go to mission controls and watch the live stream.
Okay, now come close to me, you're gonna have to rotate with me. There, okay.
I mean, I don't know what you're
You'll
doing.
see.
Oh, you're
Yeah,
saying
that's no longer clean.
Would you two be able to?
it is kind of
Okay, this is going to be complicated.
Yes. No, I've done this before. I've done like rotating.
I can't rotate this at all right now. Okay, this tube, okay, this won't work.
Yes, it will. Yes, it will.
Wait, undo.
Oh.
Okay, that's fine. Don't
Back down all the way.
Don't touch that.
Oh no.
Just stop with
It
the.
doesn't fucking matter, it's clear.
Okay, so.
I just, also that has to stay clean on the end of it. So.
Yeah.
Undo the hose. Spin the hose. Reconnect it to the.
No, this is fine.
Yeah.
It's not-
You got so many turns to go.
I have so many turns to go.
Here.
We need to think of something.
Undo that.
Wait, no, this is it, this is it, this is it, this is the, just fucking,
Dude, it's working. It's working.
that's what I decided.
People are commenting on the live stream saying it's working.
I'm gonna double check on that.
It's going. My screen is very dark.
No one is saying it's working.
Comment
Okay,
that it's
I need
working.
you to rotate or else we're gonna lose this connection.
I don't know
Comment
what
that it's not
Just
working.
continue to rotate.
You are driving the rotation. I can't.
They say it's not working.
No, what? There, that's what I'm saying, this has to rotate. They all just say.
I'm just saying. You rotate. I just this is free in my hand basically. I'm just.
So can you saying that if we had disconnected the hose, we could have
Yes.
installed the hose and then installed the regulator, and then we would have never done this like twisty thing.
Well, no, because there's NPT on here.
Yeah, but disconnect the regulator.
No, you can also do it. This is not that bad. Like, honestly, it's fine.
Oh, that hurt so bad.
What?
I just nailed my hand.
Let's just undo.
I know, I understand. This is, I know it's.
It turns, it backs out exactly how much you turned it in.
You're switching. Okay, put that in.
Put that thing back wherever it came from.
The meat, we'll figure it out.
Put that thing right back wherever it came from.
I'm going to.
Alright, before you open that,
I want a wrench. What is this rated to?
this is rated to
5 bar. No, it rated 3 bar, tested at 4 bar. I read the label the other day. So, we have a.
What is the lowest pressure you can expect to get on this range?
Oh, like, very small. Like, look at the PSI gauge on there.
Oh, I mean, yeah, but it's not as good.
Good. Alright, wait, hold on. I gotta make sure this is closed.
Okay. Alright, pressurizing. Yeah. Opening the tank. They're protected over there, and I'm just the dumbass turning it.
No, I think you're good.
Alright, pressure. We are reading roughly around 750 psi.
Okay.
And increasing pressure to, now let's be careful here because the markings are weird. So that's 50 psi, 60, 70, 80, 90. So 50, 40, 30, 20, 10. So this actually starts at 0.
Yeah, so don't exceed 60.
I'm not going to.
Yeah, no, I'm just giving you the conversion.
I'm gonna go
Okay,
let's, yes, let's do the vent.
Well, no, don't
Wait. Why?
So if we open the vents, we're not going to actually know our pressure. I could be regulating this to 20 psi, then we close our vents and we overpressurize the system.
No, no, that's true. That's true.
Yes.
Yeah.
Opening the vent. Wait, are you trying to calibrate this right now?
So
If you want to calibrate this, we have to wait until this.
Oh, someone just keep the hose.
hold on, Kevin. Let's try to figure out so the here.
We want to go to the 20 psi. We're nowhere near.
Okay, so if you set this right now to 20, no, like keep it below 20 psi.
Yeah.
Then we should be good all this.
Yeah.
Okay. So let's do that.
But it's going to take a while to fill up the tank too.
I should say 30 based on the pressure you were getting earlier, but that may be too high.
Yeah, well, the pressure relief valve is 20.
Okay, we're 20 on the nose.
All right. Yeah, that's good. Then,
Is this open?
This is flowing though, so we're still.
Yeah.
I mean, it's not actually flowing because you're a vet. You need to open the vet, but yeah.
he's talking about
Pressurized.
Yeah.
So,
Can we also get a pressure reading of the tank right now?
Yeah.
Yeah.
Like this is warm, it's condensing. We're probably evaporating right now.
Yeah, there's some amount of that. I think, I mean, let's, I think this is okay.
12.
Okay. Yeah.
Is it? Can we check if that increases or not?
What do you mean?
It should eventually go to 20.
We can't read the pressure on there.
I know that, but that's open right now. Connected to that, which is connected to that, which is connected to there. Which means there should be 20 psi.
Roughly. I mean,
It's
that
okay.
juicer is like
It's
1600. That's super.
It's 20 psi there. Yeah.
Well, this is flowing, so I'm saying we're not equalized.
You never will be.
Yeah.
Why?
Can we see
Also,
it?
this is colder, so
It's just because it's condensing.
Okay.
like what you said. It's cold. It's
Okay. Now, let's vent, right? We can do that?
Yes.
All right, let's do the vent. Let's see what happens. This might be like super awesome. Let's hope it is. Cross our fingers.
What's going to be awesome about it is just
That there's eventually going to be liquid coming out of there.
That sounds less strong than before.
I mean, that makes sense.
Why?
Oh, this hose. Super low flow rate to this hose.
This hose.
Yes. Yeah.
Yeah, probably pretty sure.
Oh, actually, I know the solution to that.
Bigger hose?
Yeah.
We have a bigger hose?
Gotta get
Where? What hose?
the half-inch one.
Ginormous short one?
Yeah. We're gonna have to connect to like.
Okay, wait. Unpopular opinion. Couldn't we technically go until the relief valve starts to go, or we're not going to flow fast enough then still, or? Like, there's a pressure drop across our hose right now. If we wanted to account for that, we could, and just regulate the regulator higher. And so there's a pressure drop across the tube, which matches the pressure we want to match.
Yeah.
We have to be really careful with closest.
Yeah. I mean, the thing is that this is gonna choke the flow. Yeah. Like I would be willing to bet that like you can't flow more than 30 hours. Like that hasn't changed it, and it should. Like you should hear a difference there. That means the flow through here is changed.
What is that?
Chicken.
Oh.
Okay, so Cameron, we need to go from the half-inch line. We need to replace this with a half-inch line because
Wait, that half-inch tube you're showing me before?
Yes.
The one that I have no connection to.
Wait, what? We need to replace that? It chokes the flow. I guarantee it. This is a very thin line. It's very long.
I think just get higher.
It could be that the condense is condensing so fast right now.
Flow rate's not like that much. Because like, how much liquid nitrogen are you actually flowing? Like that's got to be a very small flow rate going through there.
This hose?
Yeah.
That's what I'm saying.
No, like maximum. Like that's all we need. That's all it's wanting. Like, it's not like it's a very small flow rate. You're just placing maybe a liter of liquid nitrogen every 10 minutes, or every 5 minutes, a minute, whatever.
Yeah.
It's very low flow rate.
That doesn't make sense. Also, this is getting higher.
I think actually what was happening might have been that it was flat. It was like old flat basically.
Yeah.
Yeah. That would make sense.
That would also make sense. Like, come down off right now.
Yeah.
Can we get tank pressure again? How many? 14? 20. 20?
Yeah, I'm only got 14 on that.
Alright, 20 is a good number.
20 where?
20 on the tank.
You don't want 20 there.
You want 20 there and 0 here.
Oh, it's 20 in the tank?
Yeah.
That's why you're not getting any flow, because that's 22.
Yeah.
That's what we were trying to solve by having higher pressure in the tank.
What if we
Take it off.
What if we just pull the solenoid and the regulator off?
We can do it.
Just fill it up. Figure it out.
Wait, did you say you were going to put a ball valve on there?
Yeah, we'll put a ball down there, and we don't
Although
have.
that just got really quiet.
It's been like going back and forth.
The pressure's probably.
I'm not sure why.
It also did that when I was filling without this whole pressure.
Okay, so let's get this straight. That was never the problem. It's that the solenoid is choking the flow, keeping a lot of pressure in the tank. If you got rid of that solenoid, this would be like easy peasy. Or like got a much bigger flow rate.
Well, we got rid of the solenoid when I originally filled it, and it still wasn't that.
If the pressure of the tank should be like 1 or 2 psi, not 20.
Okay.
Yeah.
Did you guys dial back the reg?
Can we?
Did you?
No,
I did a little bit.
Oh. The pressure of the tank dropped to like... Yeah, your pressure's all over the place in your tank. It's like cycling back and forth between like 10 or like 8 and like 20.
Safety first. Where's the food? Please tell me about this control.
Okay. Meeting. Alright, we'll be back momentarily. So basically right now we're trying to fill the liquid oxygen tank with liquid nitrogen to chill it in, but we don't know if there's any liquid in the tank. We're trying to figure out if the tank is almost at cryogenic temperature. We hooked up 30 psi nitrogen bottle to try to force more liquid through the viewer into the tank, but really we think the problem is that the LOX tank is not letting enough gas get out. It's too small of a solenoid that's letting the gas out. So we need either a bigger solenoid so more gas can evacuate so that more liquid can come in, or we need to take the solenoid off altogether for the still process and have a bigger force venting out gas. So that's where we're at right now.
Alright, I'm gonna undo that, Greg. You clean off the step ladder.
What? Why do you take my phone now?
Yeah. If I'm gonna do this properly.
Yeah.
We're gonna be adjustable. Okay, so you're sitting at like 15 psi, and there's no way to vent this down anymore. So there's 15 psi and there's a time regulator. Yeah. With
yeah. I kind of forgot I had my phone value. Oh, back to holding the phone by hand.
oh, you know it'd be way easier undoing like the transducer. That would be significantly easier. But we need the transducer. Eventually, will we need it just while we're doing this? I don't know. Well, then we have two vent ports. We'll have to probably need, that'd be like no. Actually, that would be bad. We actually need to undo the, actually doesn't need to be Greg. Why? That's connected to the vent 60.
All right, everyone. So the status on things is that we're having trouble filling the liquid oxygen tank with liquid nitrogen, chilling it in. So what we realized we're gonna have to do is, so the issue. Okay, so basically the setup is we have a liquid nitrogen dewar that is at about 20 psi, and it's feeding liquid nitrogen through a hose and through a valve, like through a hose, check valve, another valve, into the LOX tank. And the LOX tank is actually at like, we're measuring it. It's like between 15 and 20 psi, based on the pressure transducer. So what we're dealing with is so the solenoid. There's a solenoid on the top that is letting out gas. The solenoid is open continuously. So the issue is that the dewar is 20 psi. The tank, the pressure inside the LOX tank is 15 to 20. So we're only getting like 2 to 5 psi differential to force the LN2 through the hose and through the check valve. So we're getting a really low flow rate going through into the tank. So what we're gonna have to do is, and the issue basically is that the solenoid at the top is not letting out enough gas, and it's keeping the tank at a kind of high pressure. You know, 15 psi. We don't want it at 15. We want the tank to be at like 0 or 1 psi, so that liquid just comes in and gas just comes in without having anything to. It has a higher pressure differential from 20 psi in the dewar to 0 psi in the tank. That's what we want. So we're gonna take. Right now, I think we're taking off the solenoid on the top, and then that will have a much larger flow rate, just the fitting, the open fitting on the top of the tank. Because the solenoids are actually pretty small, like the actual flow through the solenoid. So that's where we're at right now. Yes. What?
Is your meme turned into a fashion trend?
Yes, yes. I mean, my fashion trend, but yeah. All right, good. Oh, donuts are gone.
Wait.
What?
Oh, wait. I have to say something to you.
Oh, okay. John, do you wanna tell him about stuff? Yeah, here we go. John's gonna take over. John, the cameraman. Sean, things.
Hi guys, I'm back. So, I mean, alright, I'll just talk about the fill system a little bit. This is the fill system. The reason everything is bagged and taped, you know, is obviously to keep everything clean and safe as possible for oxygen use. We found out in the process of using it that frost is nowhere near a good enough insulator to actually move enough LN2 through it. And this is why we have all this foam here. It was only put here a couple days ago during the chillin testing that we've done in the past. And that we ended up in the tank pretty close to chill, but we had problems running out of liquid nitrogen. We hoped that the insulation would make it much better, and we're clearly still having problems with that. The
3 chickens. We got chicken.
Go to Bush's.
Yeah, Bush's Market across the street.
10 pieces for $5.
Good.
Yeah, it is good. We saw that and we were like, we're irresponsible not to get it. Yeah. We've had to bring pretty much our entire workspace out to the test site. So there's a lot of clean parts there, as you can see.
Oh, check out mission control.
Alright, let's go back to mission control. Let's do this. Oh, there's no engine controller, and there's really not that much of mission control right now.
Well, we'll talk about it.
Yeah.
So this is where we go to actually conduct the test.
Do you just do a loop? Like,
what?
Do you just do a loop? You just run through everything and then go through it again?
Yeah, because the viewers changed out.
Yeah, does that make sense?
So yeah, mission control. We sit down here, have laptop and computers here, and like operate the fill system and click solenoids on and off and stuff. Run the engine. So
typically that monitor over there will be set up, and we'll have the GoPro streaming from the bunker to that monitor. It'll be here, and actually that monitor stream will be what will be the live stream in future, more advanced tests. Once all the kinks have been worked out, we're really close to having it set up for our uses. Hopefully pretty soon here we'll have it set up for live stream use.
Yeah.
Because that'd be really nice.
Cool.
This is the engine setup we've got going on here.
Oh, you're live streaming.
Yes, I am live streaming.
Actually, I think we're going to try to really focus on this, so I think we can reduce the number of people just to make things a little more organized.
Alright, so we're going to be removing the live stream camera from the engine testing area just so that we can be more focused and get our engine testing underway a little bit easier.
And like things like that, and then when we're done here, it'll probably simplify what we have to do a lot. And like all the lights, we don't need the lights. We have lights now, so the lights can go in the wall if we're not taking them back with us.
Cameron, do you want to cut off the live stream or something?
Well, no. I'll tape it. I'll just tape it down.
Okay.
Pull it first.
You guys want to start on that? That'd be very helpful.
We're going to clean up?
We're gonna start putting things that we're not going to use.
Just so that, like, when we're done.
When we're done, we don't have to sit here for another 4 hours.
Yeah, that makes sense.
Tape that there. One second.
I don't know where our problem is.
Okay, I'm going to say it again. I really think this is a problem. That we are failing from.
No, that's not your problem.
I'm like, why that's not?
I think evaporation that happens in that tank is like not a problem because it cools the tank down.
Okay. Well, when you fill the tank for the Viton ring, you go from the top to the bottom. And it fills that fast?
Yeah, it's super fast.
But actually, what was the setup like?
Sitting out there.
And then you can ambient on top?
Yeah.
It's only 15 minutes?
Yeah.
So then what's the problem here?
I'm really trying to think about it. Like, actually, can you have him close that?
Yeah, Alex?
Yeah.
Can you close the vent solenoid? Let's start. Hey, John.
Yeah, let's start out.
Hey, that valve on there, that's all the way open, right?
Yeah.
Can you close it?
Yeah.
Is it closed even? Okay, it's actually closed.
This giant hole in the edge of the tank. So I gotta imagine we just need more vent capacity.
Maybe that is.
Oh! Boy!
What?
That's fucking right!
What?
Oh yeah!
What?
Liquid!
How do you know?
Liquid just came out! Yes! That's right! Stick it in it! Oh, hell yeah! Yeah!
Thanks, God.
Right!
So, our setup is get to the bunker. Oh God, that's what.
No, so the moral of the story is we need way more vent capacity.
Yeah, that was the problem.
There we go.
Oh,
Okay.
God.
Alright, so
Wait, but I took off the solenoid before and it bent so slowly.
well, let's work on
Wait,
it.
when was before?
Huh?
When was before?
Like,
Let's focus on.
Oh yeah, but then you had your evaporation alarm. You had multiple problems. Okay, so we need to plug that somehow.
Yeah.
So I'll open the vent solenoid, then we'll drop the pressure a little bit, and you get the juicer back in.
Yeah. Where is? Wait.
how much liquid's in there? That's the question.
You're at the dip tube.
Yeah, you're at the dip.
So we need the
Now, someone take a picture of that. That was
No, not right now.
Okay.
We're focusing on solving problems.
All right,
So,
sounds good. We need a juicer.
yeah.
Here's the juicer.
Okay, thank you.
You need Teflon tape with a juicer.
Okay.
All right.
Wow, I got to turn on this. Might actually do this.
That's right. Where there's a will, there's a way.
I agree.
That is how we operate.
I actually was believing this is probably possible. Okay. So that has to be open, that vent. I lost my lucky vent. Still not open yet. Can we working on it? Hold on.
Thank you.
It's open.
I need this because otherwise I'll get sprayed in the face.
Alright, lights are coming back on.
Alright, controversial opinion. What if we just use that as our locks and run the Colflow?
That's
We are.
That's what we're doing.
That's what we're doing, yeah.
Oh yeah. Oh geez, this is actually really difficult.
Oh, Jesus. Okay, for the live stream viewers watching, we are flowing and we are perfectly chilled in now.
Yeah, we need a big ass ball valve on that.
Yeah. Well, the problem is using control remotely eventually, but for chilling, we can probably put a ball back.
Or the tank, yeah, the tank chilling, we can do it. Once it's chilled in, it shouldn't be real problem. But we do need, yeah, we need to do much larger than last week. We did try and find a larger solenoid to put there.
It's a difficult problem to solve, but we can get a ball valve for now.
Or put multiple solenoids.
Yeah, in parallel, good idea.
Multiple solenoids, mufflers. Yeah.
I don't know, we can think that's a problem for another time, but.
That's right. We're gonna do it. It's gonna happen.
I really hope this. Okay. No.
Okay. I need another. Wait. No. Hold on. I got it.
And when you're done, feed the cable through the front here.
Okay. I can do that now.
Hey, John, you ready?
Come again?
All right. How is that?
Okay. Do we not want to keep filling it? Like filling it? Or?
No.
Okay. Everything else is shutting up and we're mitigating for fun. Yeah, got it.
You guys said the tank is fully filled?
Yes.
Please head back.
That has to be done. That has to be done.
That has to be done. If you want, we can do that now.
Okay, I can get this hooked up into the LN2 and LOX line and start chilling that.
Okay. So
if the tank is full, the tank should be, the tank should stay pretty cold for a while. Like there's a lot of thermal mass there, right?
yes.
If I start filling it, I'll be topping it off.
Sorry, explain that again.
If I take this, bring it outside, plug into LN2, chill down our LN2 and LOX lines, we'll start to be topping this off, right? So we just have to get that vent solenoid open. This will continue to top off.
Yeah, we may want to.
What is that? There's a little leak at the top of the tank, which isn't great, but
Where?
at the top of the LOX tank. I don't know where. We just heard it before. We weren't concerned about it.
Oh,
What?
no, that's like tape, I think.
No, there's a leak too. That's tape. But listen.
Oh yeah, I'm not talking about that.
Oh.
Okay, so what's the?
Is that okay? Or are we going to be losing?
No, I just. Alright, we gotta fix these holes.
Yeah, I know.
Okay, so process from here. I think what we can do is
We either want a full SOP or a modified SOP with this change.
alright. We calm in thing. So alright.
You think I'm now calm?
It's because you yell a lot.
I just yell.
Alright, so let's not lean on the tank. The small lock steward,
Yes.
that gets hooked up to the logs line, right?
Yeah, but if technically we would show our LN2 line first, but we could avoid that. But I can't show the injector without the LN2 line.
So you need this to do that.
No, I can plug in that to the LN2 line. I just need to connect to the LN2 line.
Okay, which means you need the hose, like this.
I need the hose, yes.
Yeah.
Sorry, I thought you meant the jumper.
It's all right. Okay. So that's open. Okay, so here's the thing. If we want to, we should. Here, follow me out. Follow me out here.
We're also time sensitive in a way.
No, because this is what I'm talking about. I don't want to do it in a way that's time sensitive.
I know, but I'm saying that we have to just be cognizant that this will affect us.
Yeah. So
how are we chilling in the injector without draining the lock tank?
There's a path for that.
there's a way to do that. So can you guys follow me out here? Just.
Jack? So, are there any live cameras working?
All right, everyone. So an update. So an update on where we are. We filled the tank with liquid nitrogen, and it's fully chilled. And so we're actually ready to start the official cold flow operations. That means that we're going to fill the tank with ethanol, get the fuel tank with ethanol, fill the helium tank with helium, fill the LOX tank with liquid nitrogen to top it off, and actually operate the valves, open them, and flow into the engine. So what we're going to do is this camera is going to stay in the bunker here. So I'm not actually going to be able to make commentary, but we're going to get a few people, a few of us on our phones out there to comment on the live stream and give live updates in the chat of what's going on. And you guys will just be here watching this view. I'm probably going to shift the camera over a little bit. But yeah, as you can see, the everything is fully chilled in. The tank is full. That's what we've been doing for the last few hours and waiting on. So now, yeah, we're ready to start the real cold flow operations. So I'm going to move the camera a little bit and then watch the chat for live updates on where we are and what pressures are happening, which tanks are being filled. Because you won't be able to see the tanks being filled. It won't look like anything. Yeah, so that's where we are. Thanks for holding on thus far. We're really excited to have so many people tuning in. All right, sorry, I'm just moving the camera right now. It's going to be a little bit shaky.